Okay, in example 13, we've got a binomial random variable because we're sampling 80 bulbs, and each bulb can either have a yellow flower or not have a yellow flower. And we're counting how many of those bulbs have a yellow flower. So let's define a variable. Let's say x is the number of yellow flowers out of the 80 bulbs. So x follows a binomial distribution because we're doing 80 trials, and the probability of success on each trial, here success means producing a yellow flower. We're counting how many yellow flowers we get, and that probability is 0.55. So we're asked to investigate this probability of x being 50. So we can work out the exact value of x being 50, either using our calculators or using the binomial formula. Let's use our calculators. So let's go to distribution, binomial, PD because we want a specific value. X is 50, number of trials is 80, and the probability of success is 0.55. So the probability of having 80 successes, i.e. 80 bulbs that produce a yellow flower, is this probability here. You also could have got this probability using the formula for the PD probability density function. It would have been n choose x, which is 80 choose 50, and then the probability of success to the power of how many successes you've got, multiplied by the probability of failure, so the probability of not having a yellow flower, which is 0.45, to the power of how many would not have a yellow flower, which is 30. And you would have got the same answer up there. This is the actual probability using the actual distribution, the binomial distribution. So what we're going to try and do is we're going to try and use this normal approximation. So we know that we can approximate this using a normal variable, let's say y, which follows a normal distribution. And we know the formula for the mean of the distribution is np, and the variance is np 1 minus p. So remember here in this formula, n is the number of trials and p is the probability of success. So we can write this down here. Our mean, which is np, is going to be 80 times 0.55. That's how many flowers we would expect to have a yellow flower, how many bulbs we would expect to have a yellow flower. So that's 44. And the variance of our normal distribution, sigma squared, is np 1 minus p. So we can work that out. That's going to be 80 times 0.55 times 0.45. And we get that that's 19.8. Another way of doing this would be to write down what's the standard deviation. The standard deviation is going to be the square root of this. So the square root of 19.8, which would get us 4.449.7. So here we write as our parameters, we write the mean here, which is 44, and we write the variance here. So the variance is 19.8. Another way of writing this, which you'll see in the textbook solutions a lot, they like to write this as the standard deviation squared. So you could have written that as 4.4497 squared. Either way is fine because they're the same, as long as you write the variance as the second parameter. So we want the probability of x being equal to 50. And we know that we can approximate that to a probability to do with y. Well, if we think about our distribution of y, in the middle we've got 44, and we're interested in this probability of being at 50. So let's put 50 on our diagram, and let's put in 49, 0.5 above, 49.5, and let's put in 50.5. Now, when we do our continuity correction, we're going to work out all of this area because that's going to approximate the bar for 50 when we do our continuity correction. So that's the we want to work out the probability of y being greater than 49.5 and less than 50.5. And we can use our calculators to work out what this is. So if we go to normal distribution, CD, and we're going to go lower is 49.5, upper is 50.5, and here we need to put in our standard deviation. So it's important that you put in the standard deviation, not the variance. So if you had written 19.8, that would be the variance. You need to square root that, and that's what your calculator wants. So we want sigma. And if we work out what that is, we get this value here. So finally, we need to work out the percentage error. Remember, this is an approximation. And it's this probability which is the actual. So to calculate percentage error, we're going to do the difference, so the actual minus the approximation divided by the actual. And then we need to times that by 100. And it doesn't matter whether you do approximate minus actual, because here we're not bothered about whether it's above or below. Here we just asked for the percentage error. So if we work that out, we'll get our answer for the percentage error. Don't forget to times by 100 to get percentage, which is 0.92% as our percentage error. Now, this answer is slightly different to the one in the textbook. That's because we've used our graphical calculators to get the most accurate answer possible.